I apologize. So we need to start again this entire exercise because we weren't streaming live, and this was me being a noob at this entire exercise. So let's try it again. Apologies for everybody that waited. I'm going to, again, for everybody else, start again, and then we'll edit the entire video. So going back to our welcome page for everybody. Thanks, and thanks for the support. Thanks for joining us. And this is the first iteration with some obvious bugs in production of the state of insecurity. My name is Božidar. I'm the founder of Beyond Machines, and we like to help people, we like to work with people to provide them with easy advice on cybersecurity so they can easily find their way around cybersecurity, easily implement it through practical guidance, through practical advice, the things that they can do easily and quickly. Because cybersecurity should not be an enterprise feature. We need to make it available for everybody, and that is part of our effort. In our first episode, with the second iteration, we're going to talk about old cryptography challenges and hints. So we are going to talk about our challenge and help people on the old cryptography thing. And then we're going to discuss a little bit on how a scam fails on deployment, because obviously even a scam can fail on deployment, and then provide some more hints of that. And finally, we're going to discuss something along the lines of save it, we may need it, which was a real incident about a company which was very greedy and decided to collect all the data they could, and then they leaked all the data they could. So given that, we are going to have a very interesting second iteration again of this first podcast. Join our Discord. You should join our Discord because we have a live chat and live discussion at the moment that people can just use to ask questions, and right now they helped me on this. Thanks everybody for helping me. It was useful. I couldn't do it without you. I couldn't even notice that there was a mistake. And apart from that, you can have a lot of support from various people on cybersecurity issues. You can share ideas, and you can help us investigate live incidents. We have about one incident per week where we gather together, do some investigation. People lose sleep sometimes they don't, etc. This is our link for the Discord, and we have a QR code. Usually cybersecurity people don't like using a QR code, but it's there nonetheless. So with that, I think we can start our first part of the session. And this is us and our dashboard. This is the cybersecurity dashboard of Beyond Machines. It is a global trend. Beyond Machines is a platform that collects data daily, incidents and advisories, and when you use them to calculate a monthly risk trend and a full risk analysis that is calculated monthly. We're not going to go deep into the risk analysis this time. It may be for some next episode. But what I would like to talk to you about in this dashboard is the state of insecurity, and really whether you're as optimistic as you should be or not as optimistic as you shouldn't be. These are the weekly trends of incidents and advisories. Advisories being things that are unpatched, critical vulnerabilities, etc. Incidents being just breaches that happen. Bear in mind that for every breach calculated here, recorded here, there are hundreds that are not recorded, not even published. So if we see a rolling average of about 20 to 25, we're really seeing hundreds, thousands maybe. So it's not a great news. And if you think that you're not going to be hit by an incident, think again. You will be if you haven't already. The impact on individual people, how many records of individuals have been exposed. Just last week, it was 12 million. The week previously, 24 million. The week before that, fortunately, only 1.7 million. And that's the good news. So in general, too many people, the data of too many people is out there and it is going to be exploited. So most impacted industries, things that you would like to track is obviously which are the most hit industries. Healthcare, IT software and technology, education, government, and retail. Usually healthcare, education, government, and IT are just swapping places between 1 and 4. So this trend doesn't move very much. These are the most vulnerable industries. We've been tracking this for almost 2 years now. It is what it is. If you're in those industries, be concerned, do your level best to secure them. I know it's difficult, I understand, it is where we are. The top threats that are going to impact us, the obvious first choice, malware and ransomware. It's business. Everybody's trying to steal your data. Everybody's trying to ransom you for data. That's why most attacks today are ransomware attacks. But second is third-party compromise. You need to be concerned about your third parties, your vendors. Are they doing their level best, just like you are doing your level best to protect? It's a discussion to be had, but it's something that you should be losing sleep about. Then unauthorized access, which is recycled passwords, old passwords, no MFA, etc. Then system misconfiguration, which is usually just exposed and easily downloadable set of data through databases without passwords, through data buckets which are open to the public, and we are going to come back to this in the final section where we discuss a real major incident. And finally, social engineering and phishing. We are here, this is what happens. With that out of the way and our state of insecurity already explained, let's talk about our challenge. So our challenge has one difficult section that seems to have stumped a lot of people, and I'm going to try to help everybody. This is not the real challenge here. This is just a simulated version of token 4. You're going to see something like this. The string is going to be the same. The URL in this part here is going to be different. This is what you're going to see on token 4. This is what you're going to have to fix, what you're going to have to solve. The message is that data is going to be moved somewhere else, to be shared in a different way, and it's going to be encrypted. So this message here below is encrypted with IS-256 CBC encryption. A very powerful encryption without a proper key, almost impossible these days to break. Where do you find the key? And I think that is where everybody got stuck. It says, do your work for the key. Repetition is the mother of all knowledge. And then there is a URL. And some location numbers or guidelines. What this is a book cipher. A book cipher is a cipher that takes a book, that takes a string that is to be encrypted, picks out either the entire word or any letter or every individual letter of the word, and then maps it out onto that cipher book, which may be the Bible or it may be any book that you choose, and you find that particular letter somewhere in the book, on some page, in some paragraph, on some word, on some letter, and then you write this 120.9.7, and then you write 105.9.5, etc., etc., until you fill out the entire message with codes instead of letters. The only way to properly decrypt it is to have the same book, the exact same printed version of the book, so you can find the exact same letter or the exact same word on the receiving end and properly decode what was encrypted on the sending end. We're not doing that version. This is a very difficult version, and this is a reference to a real cipher which was used by revolutionaries during the US Revolutionary War with the British. The problem is that the change is that we're not using this entire exercise to encrypt everything. We have a much more powerful encryption mechanism. We need the key. So what we find is just the key somewhere in the book. Our book is this web page, the URL that you're going to find, and this location is how do you find the word inside the book inside our book, in quotes, that is the key to the entire thing. So it may be something like coded example and then paragraph and then the word generated or something like that. But there's a twist. AS256 requires that the key is 256 bits. That is 32 characters, 32 bytes. In order to have a key that is 32 bytes long, you need, there are no words, or there are very few words that are 32 bytes long, 32 characters long. So you need to find a way to actually pad your key up to 32 bytes. Once you discover or suspect the key, you need to do some work with it to find how to properly make the key, the correct key, from the word, either through padding, or through repetition, or through partial concatenation or some form of concatenation of the word, but it is there. And once you see it as a final solution, you can't unsee it. But I understand it may be difficult the first time you try to use it. Finally, decryption and encryption. Don't try to program your own encryption and decryption. That is usually a failed exercise or a useless exercise, if nothing else, because not many people can, in a very short amount of time, properly implement IS. IS is quite complex, and you won't, at the end of the day, know whether your decryption is not working because you made a bug, or the library functions in a different way, or you just haven't found the key. So I strongly advise you, this is a public web page developed by some other people, not me, and you can use this web page to do the decryption. It is fairly straightforward once you find the key. So that is all the help that I can provide for you. I hope that is enough. Now, I think we can move to our second part, which is our incident, our small incident. And this happened about a week ago, and it started fairly simply with a message, with an SMS message that I received about a fake delivery package that I need to pay something for. An obvious fake message. This is a very wrong Macedonian. It says Stavka pogrešan datala žuriranje. It has, nobody in Macedonia speaks like this. In direct translation, it says record, wrong detail, update. But the sentence is completely wrong. So whoever did this, whoever scammer did this, didn't do the work properly. However, there is a link. What happened when we start to unshorten it? We got to this particular URL. As you can see, the first part of the URL is with dashes. So this is not a URL. This is not domain, subdomain, subdomain, subdomain. This is just a host name .quest. So this is an entire domain. www-poshta-mk.quest is the domain and the URL in one. We tried to open it, obviously, because we wanted to see where it goes and how to warn people better. And we got to this. It wasn't deployed. It wasn't running properly. So what happened was that our scammers, or our would-be scammers, deployed the scam, started campaigning on the scam, but they didn't have a platform where the scammed people would visit and be scammed, actually. And that was a mistake, an obvious mistake on their part. What ended up, we checked the domain existed, and it was registered on the 5th of February. At the end of the day, we could just laugh at the expert scammers, and what I guess happened is that these scammers either purchased the service of a scam as a service from somebody else, and they clicked a button, or if they built it themselves, they weren't very knowledgeable about how to build it and deploy it properly. At any rate, they started their marketing campaign. They didn't have a website. How can we learn from this? In a real situation where we build a system, don't just rely on automation that everything is going to run. You need to check. You need to check your deployment, even if it worked 100 times before, especially if you have a marketing campaign. Otherwise, people just get disappointed, and maybe somebody like me is going to rant on Twitter and warn everybody. So this particular scam just failed because nobody got to visit the site, sadly. And while we're here, a little bit more hints. So coming back to our current challenge, Byte Bridge 2025.1, scavenger hunt with 6 tokens to discover. And we start our challenge with this message. People in the yieldcat.com team are building something, and they're going to mess up security, so you should check it out. How do you check it out? Use OSINT. What we need to do now is find a way what the hackers will need to do to find that particular new platform. The only thing that we have available is yieldcat.com. But we have a tool, and I'm going to show you some of the tools. This is the first tool that I would suggest, and it's called SubFinder. It's a fairly old tool. Just in the last, I think, a couple of months, it was it is coming back to life. New developers are starting to support it. It is a very powerful tool, and you can try it on various domains. I'm going to try it here on my home domain Beyond Machines because it's allowed for me to scan my own domain, and it will scan. It will go through many different public or not so public services. All these errors are because I don't have an API key for that particular repository. But even without those, it is extremely powerful. As you can see, it is already finding subdomains. It is finding host names. Some of these will be too old, some of these will be working, but this is a great tool for you to start checking things out for some domain. And this is the usual way in which people find misconfigured platforms. Things that are alive on the internet but shouldn't be alive on the internet. Somebody registers them here on the DNS, and then they try to visit it. So let's try this one, claritybeyondmachines.net. It's not working. And then we can have challengebeyondmachines.net, which is working, obviously. And here is the final result after everything is scanned. And then we have this Damaskian online beyondmachines.net, which is very, very old, but let's see if it works. No. And then we have yieldcat.beyondmachines.net, which, lo and behold, works. And it is the old URL of our yieldcat.com platform, which is a platform for learning web vulnerabilities by breaking web vulnerabilities. You're welcome to try it, but now I'm going to come back to our current analysis. So this is one tool that you can use. It is a fairly straightforward, simple, and easy to use tool. The next tool that I would like to recommend is this AMAS. It is an OWASP project. So for everybody that's not aware, the Open Web Application Security Foundation is a foundation organization which supports web application security, and they have a bunch of amazing tools. The one that I warmly recommend is called ZAP, which is a free version or an open source alternative to Burp Suite. But for our current discussion, I'm recommending another of their tools, which is called AMS. It is much more powerful than SubFinder, and it drills down in great detail on anything that's in DNS, and even points to where that it goes, to which IP addresses, to which net blocks, etc., etc., etc. So you have a lot more information, and then you can follow up with IP addresses, you can follow up with providers to do better research for open source intelligence. So this is another very powerful tool. And finally, something simpler, but very easy to use, dnsdumpster.com, which is a web page. And you can just run it here. And we start it for, obviously, something timed out. So let's start it again. And we run it again. And it will give us something. Now, I'm not going to say that this is a better tool. It is a different tool. It provides some different records. It structures them in a different way, but you can see some things here, including TXT records, which, if you notice, the previous tool didn't show at all. So just to hide my screen for easier visibility, this is DNS Dumpster, and we just scanned it, and it gave us a bunch of information. So I recommend you start with these three, check out the results, start investigating. I'm sure you will very quickly be able to find your way onto the next challenge or the next token in the challenge. With that being said, our final section for today is our incident. And this was a real incident of a Chinese vendor. It doesn't matter that it's Chinese. These things happen to companies all over the world. This particular one is called Mars Hydro, and it is a company that manufactures very interesting products, lights for growing stuff in hydroponics, mostly used to grow marijuana. But of course, you can use it to grow anything. So grow lights that emit mostly heat. The problem is that those things are Internet of Things. They are internet connected. And Mars Hydro, in their infinite wisdom, decided to collect everything that's connected. All these devices are connected to their servers, and they decided to collect everything from them. The Wi-Fi networks to which they are connected, the passwords of those Wi-Fi networks, the IP addresses, the device's ID, operating system information, API tokens, authentication tokens, etc., etc., etc. And then they lost the data. Essentially, they leaked the data. Jeremiah Fowler, a researcher, a very famous researcher for misconfigured databases all over the world, found it. And he found that they had 2.7 billion records exposed with a total size of 1.17 terabytes. And just quickly, here are some of the things that were in those databases. As you can see, here is a password, a pass, etc., etc., and then a time zone, something, and again a password. And this is not even a hidden password. Here we have a Zixel 53382 with some password which is not properly anonymized. And have fun. Obviously, we don't have the dump here. They have masked it, but nobody knows before Jeremiah Fowler found it and reported how many people had found it before and possibly stole it, because there were IP addresses there and locations, and also there were API URLs with tokens. So you can just take a real token, connect it to this URL, you're in as somebody else. Best case scenario, you can spend their money if it's a paid API. And more of these indices and data. So lesson learned from this: do not be greedy about data. Even if you're greedy about data, establish better processes, better controls, because things leak out all the time. For instance, why should you at all keep Wi-Fi passwords or anything in plain text? If you do need them, encrypt them and then keep them. And finally, if you do need some of them, you need the current customers and the currently alive systems. Establish data retention and deletion of all data. And that is the way to be less impacted, because at the end of the day, we are going to be hacked. Somebody is going to make a mistake and data is going to leak. Manage the risk. Reduce the impact of that particular leak by reducing the amount of data that you have available in that leak. Otherwise, you're just inviting trouble. And that's not something that I can recommend for everybody, for anybody really. So with that was all the rants I had for today. And coming back to our conclusions, these are all practical things that are easy to understand, I hope, fairly cheap to implement, or at least easy to push through as awareness in the company. Not to implement, but as awareness. Start speaking in your company. Start talking about these things. Look, this has happened. Why are we piling up all this shit? This has happened. Why are we not checking on deployment? This has already happened. Are we encrypting properly? Where are our keys? Where are our tokens? Do the basic discipline, push for the basic discipline, and I hope some of what we have told you today helps somebody. In the meantime, thank you for listening, and I hope to see you next time, next month. So we'll be talking about some other interesting stuff, and I hope to see all of you and more. In the meantime, join our Discord. Thanks everyone.